I wanted to share a operation that we've found success with that uses just basic detection zones. It could be a loop detector, it could be video detection, and a couple logic steps to get transit signal priority or signal control priority SCP detectors up and running. A very low-tech solution, but can provide pretty good operations. So let's say you have a road, you don't have a dedicated bus lane. It could be 3 lanes like I've got shown here. It could be 2 lanes, 1 lane, doesn't really matter. But you know where your buses are. They are maybe in the median lane, maybe they're in the shoulder lane, whatever lane that they typically intend to be in. Your buses are going to be either 40 feet or 60 feet. Maybe you got an articulated bus or just a standard bus. But we're going to use just a basic loop detector to trigger transit signal priority in a mixed traffic situation. So the big problem is, well, how do we filter out cars and trucks? Cars tend to be, we'll say they're 17 feet at the longest. Most pickup trucks or small box trucks are going to be 26 feet. There will be trucks that are larger, and understand that this will probably trigger with a few larger trucks, but hey, you got commercial priority, congratulations. So really all we're doing now is basic math. How long is that loop occupied? We take our vehicle length, L, plus our loop detector length, divided by the posted speed limit, and convert that to feet per second. And that gives us our occupancy time in seconds. So when we do that for all the vehicles, we see a car might occupy this loop at a 25 mile an hour speed limit for 0.6 seconds, a truck 0.8, a bus 1.2, an articulated bus 1.7. If any of these vehicles are going faster, they're going to occupy it for a less amount of time. If they're going slower, they're going to occupy it for longer duration. It's very important this detection zone gets placed in a location that's relatively free flow. So you don't want to place it up by the stop bar. You don't want to place it on an approach that tends to always get backed up. There are some workarounds to address that, but we'll just keep it simple for now. So you may actually want to put it on the exit of an intersection to use peer-to-peer communication to send that signal to the next signal. Either way, you just want to make sure that that loop is in a location that's not being clogged up. It's not experiencing heavy congestion. And then it's 3 simple logic steps. What we're looking for is that detector on? Set a delay for whatever time. Let's say we're going to be somewhere in the middle. Let's say 1 second. So set a delay for 1 second, turn logic flag 1 on. If that loop is off, then we want to shut logic flag 1 off. Because what we're looking for is if detector 1 is on and logic flag 1 is on, so that detector is on and it's been on for 1 second, meaning a long vehicle is there, then turn on the SCP detector. And that, in my experience, has worked pretty well for pretty low-tech solutions, but this is it's just a good way to get a low-tech signal priority system up and running without spending too much money on AI-based video or radar or LiDAR detection or some centralized system. Just a really quick way to use low-tech solutions to get your TSP running.